here we are. The piece de resistance, the query that has kind of lingered on throughout the course because the way that we need to approach it evolves as we learn more concepts. We can solve it in many, many different ways. And so what we're trying to do here is we're selecting employee number, salary, from date, where the from date, and then we have our subquery here, going from here to here. And we're saying, hey, select us the max from date from the salaries where the employee number is equal to the outer employee number. Interesting. So what are we doing here? We learned this rule that subqueries are standalone queries, but now if I took this and I disabled this, well, I couldn't run this on its own, right? It would fail. It would be like, hey, what is S? I don't know what S is. So this is a very interesting scenario that we've put ourselves in, because what we've created here is, in essence, the correlated subquery. And so a correlated subquery, again, is a subquery that references its parent in order to have information to execute a more complex query. So the subquery is referencing the parent's information. So with a correlated subquery, of course, we're running this statement on each and every individual row, because as we process our data, we're going to be comparing the employee number from the inner result set to the data from the outer result set. And so this can be quite costly if we count this is going to take a while to execute because our subquery is not performant enough. And we've seen many ways to execute this. We did it with window functions and we did it with views. And so when we did it with views, we were able to do it with a join. And over here, we can see with a subquery, we're able to do it in the where clause and get an exact same answer. We're getting employee number, the most recent salary, and the from date. So we're getting the right answer. This is great. We got the right answer with the where clause and the subquery, creating a correlated subquery. Now, to refresh our memories, when we did it with the view, what we did is we had this view called last salary change, and we did something along the lines of join last salary change, and we did it using the employee number, because when we execute a query against this, and we open it in the SQL editor, what we basically have here is a query that's going to show us the employee number and the max from date. And we have a bunch of joins that we don't really need because we're not using that information, but just to say we're doing it and we're getting the max from date. So that is what this is returning. It's returning us two records and we're joining on employee number. And then we're saying where the from date is equal to ls max. So ls being the view, we're executing that. And we can immediately see that we're going to have to wait way less long than with the subquery. And we can prove this, and we can literally prove this. So we can see we're getting the same answer. We're getting the same information. And if we did an explain, analyze, and explain and analyze are two very important keywords because they tell us a lot about what our query is doing. They tell us exactly what the execution context is trying to do. So if we run this, what we'll see is what the query exactly is trying to do. And we can see it in steps. And you can go very deep into the query plan and looking into the execution context. And we can see how long it took it to gather and merge, when it's sorting, when it's working on something, when it's doing a join, when it's doing a sequencing, when it's grouping, when it's merging joins, and so forward and so forth. We can see all of that happen, and we can see the cost associated to that. For SQL to plan the query, it took it 1.5 seconds. And for it to execute the query, for it to go to the result, it took it 7.1 seconds. So 7.1 seconds to execute our query with the join. Interesting. But when we did our where clause and we said, hey, do it where, we select the max of the from date from salaries, and we do it where and let's give this an alias, where sp.employee number is equal to s.employee number. So this was our original query with the subquery and the where filter. Well, let's explain and analyze that and see what happens there. And so when we execute the query plan for this one, we're going to potentially see less steps, but let's see what the execution time looked like. And let's figure out, hey, what exactly is going on here? And, why is it less performant? And what we're going to end up seeing is once this is done executing, well, we're doing a scan, we're getting the results. And let's see here, we're going through indexes. There's way less steps, right? Way less steps. But the where clause is going on each individual record. So just because it shows that it's doing less steps, well, it's doing a subplan. So it's calculating a subplan. So that's our subquery here. Interestingly enough, the from date, the filter, is going to apply itself to the subplan too, which the subplan is to execute this query. It's going to remove rows based on the filter. Whereas with the join, there were more steps, but it went faster. So how long did this actually take? Well, it didn't take very long to plan, as you would expect, because there's very little steps. We have a subplan, which is the subquery. We have our filter. So, very short planning time, 0.2 milliseconds. It's nothing. Very quick turnaround on SQL understanding what it needs to do here. But it took 18 seconds to execute. And so that's where you can shoot yourself in the foot, right? Understanding how to apply these queries is of extreme importance. This looks very simple. We can read this. It seems very legitimate and, there's nothing crazy going on here. It's straightforward. You would think this shouldn't take long, but because we're filtering, because we're using a where statement, and because we're using a subquery, well, we're applying that subquery against each individual row. So SQL can't go ahead and plan ahead of time. As you could see when it did the join, well, SQL can do some stuff in the backend to kind of figure out how it's going to join the data for you. It's doing more heavy lifting behind the scenes. A where clause is heavier up front, even though the query plan is way shorter. So how would, wait, Mo, you told us we could use subqueries anywhere in the query, and you showed us from, having, and all of these places. And you just showed us that we were using a view, right? With a view over here. And the view is nothing more than us querying against a query, right? So couldn't we do something like this? And just join a subquery? Couldn't we do that? Let's try it out. It should work. And let's name it LS for last salary. Most recent salary. Then let's name this max. Just so that we properly name everything. So as LS. So we're joining as LS, and we're going to do a using. And we're going to use the employee number. Oh, wait. We don't have an employee number in our subquery. Oh. Wait. Subqueries, they can return a row set as well. They don't need to necessarily return a singular result. That's true. A singular result was only when we were using it in the select portion, or if we were using it in the where portion. When we use it in the from, we could return multiple rows. Would this be the same for join? Yes, it is. So we can do employee number here. And we can do a group by, which is necessary when we're using it together in combination with an aggregate function. Group by employee number. So if we group by the employee number, all right, we don't need this anymore because this was specific to using it in the where clause. So we're grouping, and we're getting the max from date for each individual employee. Amazing. So let's run this query on its own to make sure, we're getting the right results. So if we run this query, this is now a subquery on its own. It's not correlated, so it should return us the correct max from date. And we're seeing the correct max from date here. So it's basically doing the same as it did joining the view. So what that means is that when we join, it doesn't matter if it's a table or if it's a subquery, as long as it's a row set that we can join against, it should technically work, right? So if we do our where clause now and we say where ls.max equals from date, now we've done our join. And if we remove the explain and analyze for a second and we run this, we're going to get the exact same results as if we did it against last salary change. Now our query is less complex than last salary change because if we open our SQL editor, our last salary change had a couple of joins. So those joins we don't take into account over here. We don't need them. We weren't using any of those columns. But if we run it, what we can see is we're getting the correct salary date, and it ran way faster. So if we do an explain and analyze of this, let's look at the explanation. Let's see what SQL is trying to do. Well, okay. This looks legit. It's a slightly longer query plan. It has 17 steps, and it's sorting, and it's hashing, and it's doing the joins and everything, and it's aggregating, and it's grouping, and all that stuff. But it only took 0.2 seconds for it to figure out what to do. So it took as long as the analyzing of the where statement. Interesting. It didn't take long for it to plan what it's going to do. But it only took 3 seconds to execute, as opposed to the 18 seconds when we ran the subquery in the where statement, because in the where statement, it's running and filtering against each individual row. It's going to execute that subquery for each individual row to make sure, hey, are you allowed to be here or are you not allowed to be here? When we do a join, our SQL, our Postgres is doing a lot of heavy lifting for us in the back, and we can see that in the query plan. We can see it in the amount of steps it needs to do. And if we went deep into what each individual step meant, we would deeply understand what is going on here. And at a high level, what is going on here is that behind the scenes, the join is doing the aggregation of the salaries table against the return from the subquery that we're executing right here. So it's joining the two result sets, the two tables in the background, and then we're doing our where statement against that return, against that joined data. So by doing that, we've simplified the amount of steps the query needs to take in order to filter out the data, because joining is way less expensive than filtering against each individual row while executing a query against each individual row. We're front-loading a lot of work to the query. And we can see that in the amount of time it takes to execute, because we're doing nothing different here than, for instance, if we were to run this against a view. This is basically the same concept, but it's very powerful to understand and know where you can put subqueries and how you can use them. Because again, the basic concept of a subquery is it can return a row set or it can return a single result. And depending on in which statement in the query you're using it, it may have to return a single result, or it can return a row set. And knowing that means it's so versatile to use anywhere. We can now join against it. We can use it in our from clause. We can use it in our where clause, and we can solve for so many different scenarios using subqueries. They are so extremely powerful. And with that, we now understand deeply how we can supercharge our queries, but also we understand now that, hey, making a wrong decision or not understanding how a query executes in a certain portion of the query can be costly. If we've put our subquery inside of our where statement and then executed it against each individual row, well, it started costing us a lot of execution time. Whereas if we put it in our join statement and we just joined against it like we did when we used the view and we joined the data sets, where we're front loading all of that work off to the engine, and we have way less execution time concerns because now our data sets are merged and we just have to do a simple comparison because we have the columns available, right? So you can combine subqueries with joins. It's not a big deal, but it's about understanding, hey, when do I need to use a join to make my query more performant versus when do I need to use a subquery to calculate something a bit more complex or create a data set, a row set that effectively has all of the data that I need, right? All right, so knowing all of that, let's look at some of the operators that we can use in subqueries and how to use them.